Today we're going to be talking about the product and quotient rules and some higher order derivatives. So, the product rule is when you have two functions and they're being multiplied together. So you take the first function multiplied by the derivative of the second function plus the second function times by the derivative of the first. So what I often like to do is I like to have my students label, that one's F, that one's G. You don't have to label them in the actual problem, it's just more of a visual for those visual learners out there. And then over on the side, I've noticed some students take the derivative. So if I take the derivative of F, 3 minus 4x, and then I take the derivative of G, and the derivative of G is 4. So now I can just write out my formula. And so I have, leaving the first alone, derivative of the second, which is 4, plus, now I have the second function times by the derivative of the first, which is 3 minus 4x. And then I want you to simplify that to do a bunch of foiling and a bunch of simplifying. So when you go through all of that, I'm not going to do that in this video because honestly you guys know how to do that math, but I would recommend you do that and you should get negative 24x squared plus 4x plus 15. Now the quotient rule is a little bit more complicated when you have one function divided by the other function. And so you have your top function, f of x, and you have your bottom function, g of x. So you have low d high, derivative of the top, minus high d low, draw a line and square the below. And this is what I say in my head every time. So I would memorize that. Both of these rules you need to memorize. Just keep that in mind. So low d high minus high d low, draw a line, square the below. Okay. It reminds me, I think it's like a Snow White and the Seven Dwarfs song. That's what it kind of reminds me of. Okay, so now this example. And again, I would recommend if you have your top function, label it and take the derivative. Take the derivative of the bottom function. And now set up your derivative. Okay, so I honestly, guys, I remember the saying, low d high minus high d low, draw a line, square the below. So from here, you have your g of x function. Okay, so my g of x function, I'm going to erase this. I apologize. I couldn't see where my cursor was. So my bottom function is 2x squared plus 3 low d high minus high d low draw a line, square the below. Not the derivative, the regular function. And when I started teaching calculus again, I often forgot to do this squaring of the below. I know I had an extra parenthesis in there. And then now you have to simplify this. I don't multiply at the bottom. You don't have to worry about multiplying at the bottom. But what I do want you to do is I do want you to simplify at the top. When I went through and I simplified at the top, I got this. All over the bottom. Again, don't worry about simplifying the bottom. And quite honestly, I wouldn't even worry about trying to factor that top. Okay. Typically, things are not going to cancel, so you can leave the top unfactored. Okay, so now writing the equation of the tangent line. So I need to find the derivative. Oh, at 1. First, you know what? First, let's find f of 1. F of 1 is, when I plug in 1, I get a 1 minus a 3 plus a 1 times by a 1 plus a 2. So that ends up being a -3. So I now have my point. Remember to write the equation of a line. You need a point and slope. So I have my point. I just now need to find my slope. So now I take the derivative. And if you don't need to do that side work, if you don't need to, I am not going to. You're more than welcome to. So, and honestly, I switch up the terms. So I say derivative of the first times by the second plus, now I have to leave the first alone, times by the derivative of the second, which is 1. Now you could go through and simplify this if you want. And I would recommend you not do that. You know why? Because you might make a mistake. But if I plug in 1 here, I'm going to easily be able to find the values. So I have 3 minus 3 times by, if I plug in 1 there, I get 3. That term's going to go to 0, so it really doesn't matter. And then I have 1 minus 3 plus 1. So that slope ends up being -1. Now remember, I like to use point slope form. So y minus y1, which is a -3, is equal to my slope times x minus x1, which is 1. Okay, so now let's derive the formula for tangent of x. We could use the limit definition, and I would admire you if you did that, but now we know that tangent is sine of x over cosine of x. So I have to find the derivative of this. So I have to find the derivative of the top, derivative of the bottom. So derivative of sine is cosine. And then I will write it like this. And then derivative of the bottom, which is g prime of x. Derivative of cosine is negative sine of x. So now what you want to do is write out your derivative. Y prime equals. So low d high minus high d low. Draw a line, square the below. So now simplifying that, let's notice what we have on the top. We have cosine squared x plus a sine squared x all over a cosine x squared. Well, what's sine squared plus cosine squared? Well, that equals 1. What's 1 over cosine squared? Secant squared x. So now we know the derivative of tangent. So there's the derivatives of all the 6 trig functions. I realized that we did cosine and sine yesterday, but there's the derivative of tangent, cotangent. Look how they're kind of paired together. Just remember the co-functions are negative. Secant, secant, tangent. So cosecant's negative, cosecant, cotangent. So kind of like the co-functions, they have similar derivatives. I find that kind of interesting. Okay, so now let's go through and start finding some derivatives. Okay, so derivative of the first term is that, leaving the second alone, plus leaving the first alone. Derivative of the second. So now I have negative 8x cosine x. Those negatives cancel, so I just end up with a 4. I forgot my plus sign. Plus a 4x squared sine x. And you could, if you wanted to, you could factor out a 2x if you wanted to, or even a negative 2x, but I'm okay with you guys leaving it like that. Okay, for the second one, I think I might need a little bit more room. I'm going to kind of do a loop so that we know all of this is for b. So with the trig functions, if you have 2 functions that are next to each other, you first want to check and see if anything can be simplified. So cosecant is 1 over sine x. Cotangent is cosine x over sine x. And I guess, yes, you could technically say this is cosine x over sine squared x. And that would be great, but then you would have to do a quotient rule. And I remember being in high school. I would avoid the quotient rule like nothing else, okay? So I didn't like the quotient rule. I couldn't remember it. So I would not recommend doing that. What I would recommend doing is leaving it like it is and do the product rule, okay? So this is going to be a little bit more work. I'm actually going to do it down below here. Okay, so derivative of first. Derivative of cosecant is negative cosecant x cotangent x times by this cotangent plus, now I leave the first one alone. I'm going to leave the cosecant alone. And then cotangent, derivative of cotangent is negative cosecant squared x. Remember, the derivatives of cofunctions are always negative, meaning cosecant, cotangent, cosine. Now this is actually kind of fun to simplify, I think. But remember, I love calculus. Ooh, that should be a minus there because I have that negative side. So this should be a minus sign. And that turns into cosecant cubed x. Again, you could factor out a negative cosecant if you wanted to, but it doesn't make an identity for you to simplify even more. So that's not really the point of it. There's no value in trying to simplify it more. Okay. Higher order derivative. So we have our first derivative. And our first derivative is that and we know that notation. Now, second derivative, I'm just taking the derivative of the derivative. Taking the derivative of the derivative. Third derivative, I take the derivative of the second derivative. So it's just continuing down. And then the nth derivative is written like this. This notation is kind of new, with the number of the derivative in parentheses. That's different than squaring the function. And that's taking the derivative, say, 10 times if we had to. And I talk about this because I had a student, Nick Fusari, who always emails me, just checks on me, sees how I'm doing. Got to see him the year after he graduated. He came back to visit me for a little bit when he was in town. And so I'm smiling right now because I think, thinking of Nick, I just think he's such a great guy. And he came back to me after the AP test, and he said to me, that should be a 4. What does that mean? Like, it means the fourth derivative, Nick. Oh, did we do that? Yes, Nick, we did that. So it just makes me think of, I talk about you guys in a very loving way in future years. Okay, first 4 derivatives. So our first derivative of this is 15x to the 4th minus 20x to the 3rd plus 2x squared plus 14x minus 2. Making sure I did that right. It matches my answers. All right, second derivative. We get here second derivative, 15 times 4, 60. X cubed minus 60x squared plus 4x plus 14. Did I do that right? Yes, that was right. Now I take my next derivative, 180x squared minus 120x plus 4. And then now my fourth derivative for Nick Fusari is 360x minus 120. So a good application of higher order derivatives is particle questions. And particle questions are really, really important. It's a lot of what we're going to be doing in this class. It's a good application of calculus. We talk about it a lot, and if you're in physics, you also talk about it in physics class. So particle moves along a straight line, so that its function is given by that, where s is measured in meters and t is measured in seconds. Remember, s is standing for the position function. So find the displacement of the particle in the first 3 seconds. So the displacement of the particle in the first 3 seconds is s of 3 minus s of 0. So over to the side, I'm going to find s of 3, and I did that math already, and that is negative 1. S of 0 is the easy one, that is 8. So I'm doing negative 1 minus 8, and that gets me to a negative 9. If I give you units, you give me units back. You guys are pretty good, especially if you're in physics. Now, average velocity, that is s of 5 minus s of 0 over 5 minus 0. S of 5 ends up being 3 minus 8 over 5. That ends up being a negative 1. Now, units on velocity. The units on the top are meters. The units on the bottom are seconds. That's how I get that. Now, same question, just expanding it a little bit more. Find the instantaneous velocity of the particle when t equals 5. So when t equals 5, instantaneous velocity, remember that the derivative of position is velocity. So my velocity is equal to the derivative of this. So this is 2t minus 6. So then I find my velocity at 5, and I get 10 minus 6 I get 4 meters per second. Now acceleration. Let me go up here for acceleration. So acceleration is the rate of change of velocity. I should have that there. Okay, so acceleration is the rate of change of velocity. So acceleration is the derivative of velocity. Said another way, that is the second derivative of position. So now I need to find the derivative of, I don't know why I put a G there. So the derivative of velocity, which is our acceleration function, is equal to 2. Now acceleration is rate of change of distance with respect to time, so it's meters squared per second. So that is our video for today, the 2.3, which is product and quotient rules and higher order derivatives. Thank you very much.